Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. So the lead code problem we are going to solve today is called find medium from a data stream. It is a very nice problem. And if we see some of the popular companies where I want to get a job who have already asked this question, there are companies like Amazon, Apple, Uber, Adobe, Bloomberg, Google, Spotify, Microsoft, Facebook, Nvidia, ByteDance, LinkedIn, and bunch of more. So that's why I'm paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode hard problem and also a very well-liked problem. Basically, we need to find the median from an incoming data stream. Now, in this problem, basically we are being asked to implement the median finder class. Now in this median finder class, we need to implement these three methods, where the first method is the median finder method by itself. Second one is a void add number, which means that if this method is being called, it will add an integer called nums from the data stream to our data structure. And third one is the find the median, that we need to basically find the median. Now let's come back to the problem statement. First, we are given the definition that what a median is. Median is the middle value in an ordered integer list. Now this is the tricky part. We are being asked to find the median from an ordered integer list, which means that the input, whatever the input comes, let's say the input comes like 11, 3, 5, something like that, we still need to find the median as if the input was 3, 5 and 11. So this is the tricky part. Like most of the people would not realize that the wording ordered integer is there, and then they will get confused. So now we have get that sorted. Now we need to see that what is the definition of the median is. Basically median is the middle value, and if the size of list is even, then which means there is no middle value. In that case, we need to find the median as the average of two middle values. And we are given some examples, but we are going to see this in much broader examples. So first let's try to understand this with some existing example. Suppose we are given a stream that looks like this: 1, 2, 5, 11, 15, 16, something like this. What would be the median in this case? Well, if we go based on the definition currently, well, this stream is actually an even stream, which means that there is no exactly one middle value. We are currently seeing two middle values in this case. And also notice that for this whole thing, I actually set it in ordered motion already. So we are going step by step. So first, this is an ordered list, that is an even list, and it has two middle values. So in this case, the median is going to be the average of these two values. So which turns out to be 5 plus 11, 16 divided by 2. So the answer is going to be 8 in this case. So second, again, let's suppose that once again the list is ordered list. So 1, 2, 5, 8 and 9. In this case, we are dealing with odd numbers. Now for these odd numbers, the middle value is quite obviously clear, and that is going to be value number 5. And again, the ordered property is still maintained in this example as well. So in this case, the answer is going to be simply value number 5. Now let's take one notch a little bit more complicated. What would be the median in this case? Since this is odd number, we know that we need to find the middle value, but in this case, this is not in order. So first we will have to put this in order. So that is going to be 1, 3, 5, 8 and 15. And in this case, now since it is easy to calculate the middle value, it is going to be 5. So this would be another scenario. Now with these examples, you at least got one broader idea that how to deal with the median finder class. Like when we need where we need to first of all create a method to find the median. Second, we need to create a method to add the median. And third, we need an object of this median finder class. So basically we need to focus on these two items the most. Now the most important part in this one is first we will have to see that what would be the actual problem is going to look like. So actual problem is going to look something like this, where there can be multiple options. So first, let's say that it selects, and the option is that you need to find the median. But currently, if we see our list or our input data stream, let's just mark this as input data stream. Currently in our input data stream, there are no values, which means if we call out this find median function, basically it is going to return 0. So this time, or return null value, actually not 0. So let's say that this returns the value null. Okay, now again we are calling add number method. So if we call add number method and we say that okay, add number 5. So in this case, currently in our data stream there is only one value, that is 5. Now we call add number method again, and we add value number 6. So now our data stream has value number 6. Once again we call the add number method and we add value number 2. So in this case, currently our data stream has value number 2. And then if we call the find median method, which means we will have to find the median. Now in this case, ideally this find median method should give us the answer according to all of these examples we saw. So basically, first for this data stream, it's 5, 6, 2. So we are going to put it in the ordered list, that is going to be 2, 5 and 6. And the answer in this case needs to be returned as value number 5. So 5 is what we would return over here for the find median. Now again, there can be bunch of more operations to be performed same way. So let's say that again we add a number and this time we add the number 11. So our data stream is going to have value number 11. Now if we want to find the median, then again there would be an additional bit of changes. So it would be like, this would be our sorted data stream, and the median is going to be 5.5, and this is what we will return. So basically it will keep on changing. Now our job is to do this in the most efficient manner. Okay, now in this array list, what we are going to do is from whenever our main method, whenever we see add number method being called, we are going to simply push one number down this data structure. So let's say we got numbers coming in as 6, 8, 2, 1, 5. Okay, this is the sequence of numbers that came in, and then we encountered the find median method. Now again, since this is a brute force approach, we are going to take this step by step in the very preliminary fashion. So first thing that we would do is that we need to find the median of this array list, but currently this array list is not sorted. So because this is not sorted, we are going to simply sort this. Now sorting an array or array list, actually there are a bunch of different ways, but typically this can be achieved in n log n time if we use something like quick sort or merge sort, but we are not even going to bother implementing those quick sort or merge sort. What we are simply going to do is call collection.sort method. So if we call collections.sort method in any programming language, basically it sorts the given array for us in n log n time. So after that, we are going to have a sorted array, and the sorted array is going to look something like this. It's going to be 1, 2, 5, 6, 8, and this sorted portion took us n log n time. Okay, now for this now finding the median, it becomes quite simple, because we know that for array fetching takes big O of 1 time, and also putting the value takes big O of 1 time. We already know the size of the array, so in this case the array size is going to be 5. So because array size is 5, we know this is odd number, and since this is odd number, we need to find the middle value. So middle value has to be located at position number 3, or if we see in the array, it has to be sorted array, and the index value has to be 2. So because this is 0, 1 and 2, and whatever the value is located over here, we are going to simply return that, and that is going to be our answer. So let's break down how does our brute force solution compare to everything we have done so far. So it actually seems to do justification, because if we see in this case, the finding median is being done through two processes. First process is that we are sorting the given input, and second process is that we are actually finding the median by doing the average depending on the odd or even value. Now this case is a constant operation, so this can be done in big O of 1 time, but the sorting is actually a little bit tricky, and this takes n log n time. So overall, the finding median is going to be done in n log n time, and adding number is actually quite quick, so that is being done in big O of 1 time. So if we see the total time complexity in this case, the total time complexity for this brute force approach can be considered as n log n, and that is not so bad, but we want to do it in much faster manner. So we will have to strive for something that where we can store or where we can save in terms of time complexity. Well, optimal solution is actually comprised of couple of different components, and what those components are, first we will have to find the room that where we can actually save in terms of time complexity. So we are currently taking care of finding median by using first sorting the given input, and second one is finding the actual median. Now this portion is quite easy, so we can ignore this one. This portion is the trickiest. And why this is the trickiest? Because we actually have an incoming data stream that is generating bunch of different random numbers, and we are taking these random numbers and creating them in a beautiful sorted list. And this sorted list is then being used to find the median depending on the middle values. Now, since we already know that the input that is coming in at one at a time. So if the input is already coming at one at a time, why can't we design a structure that automatically sorts itself? And we are not going to need to care about the sorting property. So we already took care of one portion of it. And what would be that automated sorting mechanism data structure is? Well, you already know it. It is actually called a heap or a priority queue, where depending on the how you configure it or how you set up, you can actually configure it to have in either in increasing order or decreasing order. So no matter the sequence of numbers that are coming in at random, eventually this is always going to be in the sorted manner. So if it is always going to be in a sorted manner, then it becomes very easy for us to basically find the median, because we already know that how to find the median from a sorted property. Now there are a couple of tricky parts over here, and first let's break those down. Currently we have already decided that we are going to use heap. Now what are the trade-offs with heap? Well, the first trade-off is that if we want to insert any data, basically the insertion takes big O of log n time, right? So that is adjustable because it is maintaining the sorting property. So how it does it is that let's say that you have this initial heap that is being created, and currently this heap is empty. Now you have this one incoming value 15 coming in. So 15 comes in. So it currently, because there are no values, it puts 15 as it is. Now let's say that there is one more value coming in, and that is value number 16. So now for this value number 16, heap is not just going to append it anywhere in the sequence. It is going to see that, okay, let's assume that this is actually a min heap, which means that the topmost value has to be the minimum value and all the other values would be greater than that. So in our min heap, basically we need to make sure that the first value remains the smallest and everything is sorted in increasing order. So in this case, because of this is a min heap, it is going to put 16 over here and 16 is going to store over here. Now suppose we have another value coming in, and that is value number 5. Now this value number 5 is actually lesser than 16 and 15 both. So in this case, it is actually going to find a proper bucket or a proper place for 5 to be stored, and that it is going to do using the binary search. And we all know that binary search takes log n time. So that is why first it is going to do the binary search to calculate that where to put this 5. It calculates that, okay, currently the 5 is the lowest or the minimum value, so that is why it is going to put 5 at the beginning, and it is going to take care of all the other values. So basically our heap is going to look like 5, 15 and 16. And because of this property, there is this log n time penalty that we have to pay. But this log n is actually much better than n log n because we are only doing it once. So that is the trade-off. Now I hope I was able to explain you that how does a heap work. Once we have that sorted, now let's see that will this make any improvement to our problem? Well, of course, it is going to make significant improvements to our problem. Currently, let's assume we are using a min heap. Again, using the same example, let's say that we have our data stream. Now in our data stream, assume that we have all the values coming in at random. So the random values that are coming in at the moment are going to be, let's say 1, 15, 3, 8, 9, 11, 13. Okay, these are the random values came in, but we have a heap and we have a min heap, which means that is going to take care of all the values in the sorted manner. So sorted manner is going to be, now in this case, since we have 7 digits or 7 values stored inside our heap, which means that this is odd number. So because this is odd number, we need to find the middle value. Now this is the tricky part. We know that with array, it was actually easy to fetch any value from the middle because we were able to do it in big O of 1 time constant time. But that is not the case with the heap. So fetching the middle value, it is actually going to take big O of n divided by 2 time, because we are doing it sequentially, one by one, to reach to the middle point. So in that case, since it is taking that much time, can we do some improvements to actually find the median quicker? So now we know that what is the issue with the typical ordered list. Basically inside the ordered list, despite having all the values properly set up using the heap, it will still take us time to reach to the middle pointer, and we want to basically make this process much faster. So how do we do that? Well, one simple conclusion is that breaking this heap into 2 portions. And how do we break this heap into 2 portions is that first we are going to have a max heap. Now what does a max heap means? Max heap is going to be this portion of the given existing list. And if you notice, one property in this portion is that every single element at the end of this heap is always going to be the maximum value compared to all of its peers. And this is the only value we care. Same way, we would have another partition being made inside our heap, and that is going to be this remaining portion. Now inside this remaining portion, we can actually call this min heap. And why we are calling it min heap? Because the only value that is of concern to us is this middle pointer. We don't care about all of these values. We only care about this value because this is going to be the minimum value compared to all of its peers. And if, for an example, if the current heap size, or if let's say that max heap and min heap, we will try to make them exact equal in terms of the number of elements that are currently present. So let's say that in our current data stream, if the values are even, basically in that case, max heap and min heap, they are going to have even values. And in our data stream, if the values are odd, then in our case, our max heap is going to have one more value compared to our min heap, and that's it. So if the values are even, or if min heap and max heap are same in the size, then the median value is going to be the combination of, or the average of, this max and min heap. And if it is odd, basically we simply need to return this max heap value or the max element. Confused? Don't be. Let me show it to you with an example. Suppose this is our current data stream. What would be the ordered list? First, let's just try to understand. So median in this case, again, that is quite easy to find. The median is going to be this value number 3, that is the middle value. And why we came up with this value number 3? Because once again, this is the total number of elements are in the odd number, so that is why it is easy to find the median. Now let's see that how would my approach work. So first, let me quickly create a max heap and a min heap. So I'm just first giving you the end result, that how they are going to look like, and then we will go step by step on how to implement that. Okay, so end result is going to be that this max heap is going to have all the values that are greater than the very first element inside the max heap. So max heap is going to look something like this: 3, 2 and 1. Actually it's going to be 1, 2, 3, but I'm giving you more general idea so that visually it is more interesting that the very first element is the element that we are looking for. So in this case, this is going to be that. And if we see it with the original list, basically we are taking care of these first 3 values. Same goes with the min heap. What are going to be the values? So the values are going to be simply 4 and 5. Why? Because the very first element is going to be the minimum value compared to all the other values. Now again, going back to our equation of the values being equal or one value being higher than the other. So in this case, currently if we see the number of values, in our, okay, this mh is not the best abbreviation, in our max heap. Okay, max heap and min heap. So currently in our max heap the number of elements are 3, in our min heap the number of elements are 2. Because max heap has one greater element, the whatever the value of max heap is, or the whatever the value of the very first character in the max heap is going to be our median. And in this case, if we were to ask the find the median, we can simply return the answer as 3. Now let's see that how step by step we are going to maintain this property. So first we have our max heap, and then we also have our min heap. Now the property inside the max heap is that the very first value has to be the biggest value compared to all the other values, and the min heap is that the very first value is going to be the smallest value. And also there are one more property, that every single value inside the max heap is always going to be less than or equal to the min heap, nothing more than that. So first we are going to enter the value inside the max heap, and that is this very first value 52. So first we add 52 over here. Currently min heap does not have anything, we took care of this value. Now the second value is value number 2. First we are going to check the size difference between max heap and min heap. And what the size difference is going to tell us is that whether the value should be added to max heap or min heap. So if we were to add this value number 2 to max heap, then the size difference between max heap and min heap is going to be value 2. So because this is greater than 1, we cannot have them, which means we will have to push one value to the min heap. But the question is which value, and that is the interesting part. So we know the property that every single value in the min heap has to be greater than max heap because of this one. So if we enter value number 2 in the min heap, will it make sense? No, absolutely not. Which means first we will have to push the maximum value that is currently present inside our max heap to the min heap. So the first we are going to have value number 52 being pushed over here, and then we are going to have this value number 2 being pushed to our max heap. I hope this makes sense. If not, try to rewatch the video for this portion and you will understand what I exactly said. So now we already took care of value number 2 as well. And also remember, because we have both the values at the same time, if we want to find the median, it becomes quite easy. We can do it in just constant time at any given moment. Because let's say I tell you that after these two values there is a find median command. You can do it quite easily. You can just say that okay, 52 plus 2, 54, 54 divided by 2, I think it's going to be 27, and 27 is the answer. You can find it quite obviously. So that is why this approach is very fast. Now again, going back to our example, now this value number 3 we need to push in. Currently both of the min heap and max heap, the sizes are same, which means the value has to be entered into the max heap, because max heap can have one more value than the min heap. So 3 we know we have to push it into the max heap. Now what is the property of the max heap? That very first element in the max heap has to be the greatest element or the biggest element compared to all the other values. So in this case, because 2 is the small element, we are going to adjust our max heap. So first element is going to be 3 and second element is going to be 2. Now we took care of this value number 3 as well. Now we have this value number 5 to take care of. Again, 5 has to be added to the min heap. So if should we add 5 directly to the min heap, or should we add it to the max heap? We are going to check the very first or the biggest element inside the max heap. The biggest element of the max heap is lesser than the value of that we are trying to enter, which means 5 can easily enter our min heap. So since we are entering 5 into the min heap, we also want to maintain a property inside the min heap that the very first element inside the min heap is always going to be smaller, which means 52 we will have to move on the side and value number 5 we will have to put together. Because up until this point, even if you see that what are the elements, so the original elements were 52, 2, 3 and 5. If you just want to put them in a single ordered list, the value is going to look like 2, 3, 5 and 52. And we are only concerned with these two values 3 and 5, and which we are able to make sure or use using this min heap and max heap. So that's why we are going to get rid of all of this. This was just for explanation purposes, but you get the idea that what we are trying to do. Now again, once again, we have the value number 11 that we are trying to enter. So for this value number 11, it has to go to the max heap. What is the property of the max heap? That the very first value has to be the biggest value. So currently the value is 3. So because 3 is smaller, so 11 will go over here in the middle, in the very first value. So we are going to get rid of these two, and the value is going to be 11, 3 and 2. And currently what is going to be the median value? The median value is going to be value number 11, the biggest value of our max heap. But question is, can 11 stay there? Of course not. Why not? Because every single element inside the max heap has to be smaller than every single element in the min heap. And currently we have value number 5 that is actually smaller, that is residing in the min heap. So that should not happen. So once again, we will have to first, before adding 11 over here, first we will have to add value number 5 over here. And then since the size differences between max heap and min heap is greater than 1, so 11 would rather going there, it would enter over here. And in this case, the values are going to look like that 11 and 52. Okay, now we have the very final element 7 that we need to enter. So where should 7 go? Again, this already has one element greater, so we know for sure that 7 has to go to min heap. But 7, we are going to compare 7 with the very first element. So 7 is greater than 5, which means 7 can easily go into our min heap. And since 7 is the smallest element, we will have to make adjustments before we enter 7 over here. So the values are going to be 7, 11 and 52. So in the end, we are going to have our two min heap and max heap. So max heap is going to look like 5, 3 and 2. And the min heap is going to look like 7, 11 and 52. And now if we are being asked to calculate the median, it is quite obvious. We are just going to do addition of 7 plus 5. So our value is going to be 12 divided by 2. And the answer is going to be 6. And this is the beauty of heap. And this is why this problem is a hard problem, but also very popular problem. Let's calculate the time and space complexity. So again, for the time complexity, first we need to find that for the max heap and min heap. So insertion takes log n time, and essentially we are going to be inserting values in the max heap, min heap, sometimes from max heap to min heap and sometimes from min heap to max heap. But in either case, we are going to be achieving that in log n time. So essentially we are doing log n 4 times, and then for the one time we also have to enter the value from the data stream to one of the heap. So essentially we are actually doing the log n operation 5 times. So if you want to be very specific, you can mention 5 log n to be the exact time complexity. And plus, in order to find the median, this operation is actually constant. So big O, that is being done in big O of 1 time. So this is a very good time complexity. Now let's calculate the space complexity. So space complexity is basically going to be big O of n, where n is the number of values that are currently present inside the incoming data stream. So here is the coding solution. First of all, we are creating our class called median finder, where we have our two priority set. First one is a priority queue named low, that is our max heap, and second one is our min heap. Now we need to create a method to add number. Basically, to add number, we are first of all adding it to the max heap. Then we are balancing both the heaps, and then we are checking that if they both are maintaining the proper sizes or not. If not, we would pop the element and move it to the other heap. And in the end, it becomes quite easy to find the median, and that is essentially you just check the size. If the sizes are equal, then you do the average of both the lowest and the highest value and divide it by 2. Otherwise, you take the value from the max heap and return it as the answer. So let's try to run this code. Okay, seems like our solution is working as expected. Let's submit this code. And our code runs decently efficiently, and I would be posting this solution in my GitHub. So this is my GitHub repository, and you can find bunch of different solutions over here, and it is going to be quite useful. Good luck.